In this video, I will be discussing Latin square design and how we can use it to design experiments with multiple variables. Latin square design allows you to test the effect of an independent variable on a dependent variable, as with any other experiment. However, it also factors for blocking variables. There are three main components in a Latin square design experiment. These include the rows, columns, and treatments. The number of rows must equal the number of columns and vice versa. As seen in the table below, in the first row, you have A1, A2, and A3 columns. There are the same amount of columns as there are rows in the rows B1, B2, and B3. And all the boxes inside the box that contain D1, D2, or D3 would be considered the treatments. Moving to the next slide, you can see in the chart we have expanded to four different variables, A, B, C, and D. You can see that in every column and every row, there is an equal amount of treatments. So, as highlighted, the first column has an A treatment, a B treatment, a C treatment, and a D treatment. And the same can be said for the first row. This same concept applies to every row and column throughout the table. Using Latin square design has many pros and cons. One of the pros includes it allows us to factor for variables that indirectly affect the outcome. This is highly useful when considering geographic location effects. It is also useful when you want to control variables in two different directions, so looking at the row as one direction and the column as another direction. There are several cons. These cons include that there is no interaction between blocking variables, and this can be interaction between the different treatments in each row and every column. The experiments can also get very large with increased treatments, so as you can imagine, as your treatments increase, your box will also increase, making it a nuisance to work with. Applying this to an engineering example, let's pretend we are looking at four different corrosive preventive chemicals that are to be used at launch pads at Kennedy Space Center. You want to see the effect that geography has on these different testing locations. So, we are going to use Latin square designs to create an experimental design to factor for all treatment effects. Our geographic variables will include proximity to ocean, exposure to sunlight, exposure to wind, and proximity to rainfall. The fixed effects, which are going to be our chemical treatments, we are going to name W, X, Y, and Z. The diagram below depicts the different geographic locations for rainfall, wind, and the proximity to the ocean. Gray arrows indicate wind, blue raindrops indicate rainfall, and the block to the right indicates ocean. You can see in every row and in every column there is an equal treatment. The column closest to rainfall has W, X, Y, and Z, and the column closest to ocean also has W, X, Y, and Z. The same can be said throughout all columns and rows through this box. However, we have to remember that this does not look at the effect that both geographic locations have within the columns and rows.